Hey guys, in this video, I'm going to teach you how to simplify radicals that have variables with exponents. So before we dive into that, let's take a look at some exponent rules that you've learned in the past. So first, what is x to the third squared? Well, if you remember, a power to a power means you have to multiply the exponents. It's kind of like this is being distributed to each exponent inside the parentheses. And then 3 times 2 is 6, so you get x to the sixth. And I got that answer by multiplying the exponents. Now remember that this works because x to the third squared is really x to the third times x to the third, which means you would take the two exponents and add them together, because that's another rule that we learned. Keep the base, add the exponents. 3 plus 3 is still 6, okay? Now, taking a square root of something is the opposite of an exponent, or a root of something is the opposite of an exponent. So when you take the square root, the opposite would be squaring. So essentially what we need to do is take an exponent and divide it by 2, because that is the index number, which we learned about when we started talking about radicals. So for this one here, we would take the 6 and divide by 2 and get x to the third power. Okay, that means x to the third times x to the third gives us x to the sixth. So if you go backwards, you just have to divide by 2. But what happens if the square root is not even? In that case, we have to rewrite the exponent before we can take the square root. So remember that you can split it up as long as the two exponents add together to make the original exponent. But for our purpose here, what you need to do is subtract 1 every single time. So if I take 7 and subtract 1, I get 6. So that means that x to the 6th times x to the first is the same as x to the 7th. So now I have the square root of x to the 6th times x. Now I can take the square root of x to the 6th. It's the same as what we just did a moment ago. 6 divided by 2 is 3, so I get x to the third outside the radical. But I cannot take the square root of x, so that's going to stay inside the radical like this. Now, it's important to know that when you're simplifying these types of problems, the biggest exponent you can have underneath the radical is 1. If you have anything bigger than 1, it's not done being simplified. All right, but what about if there's more than one variable? So if I have x to the 16th, y to the 11th, you're going to look at each variable separately. 16 is even, so I'm going to leave that one alone. 11 is not, though, so I'm going to split that up. So I said x to the 16th is going to stay the same. And remember, you can split the radicals up too, just like we did last week. Then we're going to have y to the 10th, because I'm going to subtract 1, and y to the 1st, because 10 plus 1 makes 11. The square root of x to the 16th is going to be x to the 8th, because 16 divided by 2 is 8. 10 divided by 2 is 5, so I get y to the 5th, and then taking care of those, and then I'm left with y to the 1st underneath the radical. That would be the simplified version. Now, if you turn the page, you'll see some more practice problems. X to the 8th, it has an even exponent, so all I need to do is divide it by 2. 8 divided by 2 is 4, so x to the 4th is my answer. Number 2, square root of x to the 12th. Once again, 12 is an even number. 12 divided by 2 is 6, so I get x to the 6th. Number 3, square root of x to the 22nd. Once again, 22 is even, so just divide by 2, you'll get 11, so I get x to the 11th. Now, number 4. This is the first one we've got that is not an even exponent. So I'm going to subtract 1 to start. So I'm going to have x to the 6th and x to the 1st. 6 divided by 2 is 3, so I get x to the 3rd. And the x to the 1st is going to stay inside the radical. Number 5 is x to the 13th, which is once again not even. So let's split it up. We have x to the 12th and x to the 1st, because 13 minus 1 is 12. 12 divided by 2 is 6, so I get x to the 6th, and the radical x just stays inside. Number 6 is also not even, so I'm going to subtract 1 from 31 to get 30. So I have x to the 30th and x to the 1st. 30 divided by 2 is 15, so I get x to the 15th, radical x. The last 3 all have multiple variables, so we're going to do them one step at a time. 5 is not even, so let's split that up. I'm going to get x to the 4th and x to the 1st, because 5 minus 1 is 4. The 10 is even, though, so I'm going to leave that one alone, y to the 10th. 4 divided by 2 is 2, so I get x squared. 10 divided by 2 is 5, so I get y to the 5th. And then I'm just left with x underneath the radical. Number 8, 14 is even, so I'm going to leave that one alone, x to the 14th. But 17 is odd, so I'm going to subtract 1 and get y to the 16th, y to the 1st. 14 divided by 2 is 7, so I get x to the 7th. 16 divided by 2 is 8, so I get y to the 8th. And then I'm left with this y underneath the radical. Last one. 6 is even, so I'm going to leave that 1 as x to the 6th. 9 is odd, so I'm going to split that one. 9 minus 1 is 8, so I get y to the 8th, y to the 1st. And 4 is even, so I'm going to leave that one alone. 6 divided by 2 is 3, so I get x to the 3rd. 8 divided by 2 is 4, so I get y to the 4th. And 4 divided by 2 is 2, so I get z to the 2nd. And the only thing left underneath the radical is y to the 1st. And that's it. That is how you simplify radicals with exponents underneath, that's how you simplify radicals that have variables with exponents.